It's space weather! It's about 3:48 in eastern PA here, Lehigh Valley. And the temperature, what do we got? Can you see that? Temperature is it's a heat wave, 12 degrees Fahrenheit. So let's look at something a little bit warmer, like the sun and 171 angstroms, yeah? See that active region that we were looking at yesterday rising? And a second active region springing up out of nowhere. Check it out. Could be a sunspot, people. Here's the magnetic lines at 193 angstroms. Looking right down that cavernous, persistent coronal hole. And we see a bunch of field density over here. No surprise. Here you can see the coronal hole rotating through at 193 angstroms. Next we'll have a look at the real-time solar wind. Looks like the BZ is dropping below zero here. That's an increased earthquake risk when the BZ is very low. Phi angle is looking like it's around 315, so no sun to earth connection currently, but there should be one associated with that coronal hole anytime. Solar wind density down to 6.83 protons per cubic centimeter. Solar wind speed has continued to subside to 334 kilometers per second. Look at some other data here, spaceweathernews.com. Tiny uptick in X-ray flux, but nothing resembling a flare. Magnetometer seems to be in a smooth range. KP index has dropped down to 0, and yes, there is a cosmic ray human health alert in effect as we see an uptick in cosmic rays. Here's your Cygnets forecast. Actually, that's old data. You see the electron flux has dipped again. No charging hazards. And another anomalous F2 ionosphere day. Check it out. Very discharged in the north. And odd charge disparities in the south. Aurora forecasts are weak. Look at earthquakes at globalincidentmap.com. Last 13 hours. We've got a 4.8 in Tonga, so Tonga should be on alert for a 5, as if they're ever off alert. Argentina gets a 4.2 at depth. Argentina should be on alert for a 4.5. Japan a 4.3. New Caledonia 5.5. I think that's the largest one. Nope, 5.7, also in New Caledonia. 3.3 in Chester, California. Located quite far inland and very far north. It's actually a pretty weird quake there. Also got a 4.7 in Alaska. That's way out at the end of the Aleutian chain. No other quakes of note. Practically out at Kamchatka. Moving on to volcanoes. Volcano uptick also. Check out Stromboli. Amazing magma fountaining. When lava when magma becomes lava before your very eyes. By the way, those are happening every 10 to 40 minutes. That's Stromboli. Bazimiani, with an uptick there, a 33,000 foot ash plume. Sakurajima, 7,000 foot ash plume. Tacoma, 7,000 foot ash plume. Revenador, possibly exhaling volcanic ash. Planchon Peteroa, 14,000 foot ash plume. And don't forget Kluchevskoy. I'm not going to try to pronounce it. Moving on. Despite the active region rising on the eastern limb of the sun, we actually see a drop in the F10.7 flux. As of yesterday, down to 69. Would not be surprised if that upticks soon because, well, we see an active region rising. Next, we'll take a look at magnetosphere movies. Here's the velocity. And honestly, the whole environment around the magnetosphere turns into a low velocity zone here at the end. Check it out. Let that end part play through again. Actually, it turned into more of a high velocity zone. Here's the density, which is obviously going to drop off also. See some low density waves coming in from the left. That's the solar wind. And they're very low density coming in, weakening the magnetosphere up to the current moment. And here's the pressure, and boy does it ever get weak. Drop off right near the end here, right about there. And that is what you call a weak magnetosphere. Now, often we see that magnetospheric weakness accompanied by major ground magnetic perturbations. This time I don't think we really see that, but let's let that play through anyway. There was a bit of a pulse there associated with that drop in the solar wind. Here it is from the poles. So we got mainly North Pole perturbations. A little bit in the south. And then a sudden pulse out of both poles. Moving on. Next, let's look at the Gong 2, which is using ground-based magnetometers on Earth, magnetometers on stereo A and on stereo B, to get some idea of the magnetic environment here. Keep in mind this is subject to change without any warning, and it regularly does. Let's just advance to the last frame here. We should get a magnetometer spike, a small one, when the Earth reaches this region, just before crossing the current sheet again to this region. And that should be a pretty strong connection again there. So we'll be keeping an eye out for that. It's not for a couple of days. Now let's look at the cosmic ray situation. By the way, we will leave links to this and all other sites we visit. If you haven't been watching the past couple days, here's the Athens neutron monitor. We see an uptick in cosmic rays there. Here's Mexico City. We see a recent relaxation, but an uptick in cosmic rays there. Also cosmic ray uptick in Moscow. Regarding Oulu, Finland, we see a smaller uptick and a smaller range, but still an upward trend here. Here's DOMC Antarctica, which had a very large spike on the 16th. And an uptrend recently, and DOMB showing us an uptrend also. Now let's look at the Burst Alert telescope here. Sagittarius A star, looking at the transients. Here you have the first bit of 2019. Looks like A star had a bit of a New Year's Eve party there. And since then, well, it's switched on a little bit, but that's something to keep an eye on. Here's Cygnus X3, a massive radio source in the Milky Way. This is the, quote, black hole, end quote, that Stephen Hawking and Carl Sagan famously bet. Whether it's a black hole or not, we'll just stick with massive radio source. And so this has actually trended down a little bit, as you can see here, in the past months. Next, let's look at Cygnus X1. Wait a minute. Scratch that. This is not the one Sagan and Hawking bet about. This is Cygnus X3, which is we'd call it a blazar, located about 1,200 light years from Earth. This one here is Cygnus X1. That's the, quote, black hole, end quote, that Sagan and Stephen Hawking bet on. And regarding X1, there has been an uptick in 2019. So, a lot of cosmic rays and radio signals coming out of Cygnus. Now let's look at Cygnus A. This is a massive radio galaxy. And constantly sending out strong transients. Small uptick since 2019 began. For those of you not familiar with Cygnus A, one of the strongest radio sources in the sky. There's an image of what it looks like. See radio jets on either side. And your massive source of radio signal in the middle. We'll include this article in the links also. Here's another article about Cygnus A. Talk about a crazy galaxy. Next, I'd like to show you astrotes.info, a great private observatory, the Holland A. Grotch Observatory in Scottsdale, Arizona. Got some great images. Here's M31, otherwise known as the Andromeda Galaxy. And here's M101, known as the Pinwheel Galaxy. Finally, let's look at spaceweather.com. For anybody who viewed the total lunar eclipse last night or didn't, here are some images. Here's a close-up of this active region. In 304 angstroms. Zoom out so we can see the filament activity. And there's quite a bit of it. Thanks for tuning in, everybody. Thanks, subscribers. If you enjoy the content, please don't forget to like and subscribe the videos and share on your social media. As we approach 900 subscribers, we are taking suggestions as to what to do for a 900 subscriber special. We'll be doing it all again tomorrow. Now remember, on your way to freeze, don't drink. And if you drink, don't freeze. And also don't drive.